Can large language model agents build agents for us? Is this the future of software development? Today, we are going to put it to the test. I spent one afternoon using Cursor AI agent to build 5 different large language model agents from scratch. The AI did almost all the hard work, implementing them from scratch with my open-sourced 100-line large language model framework called Pocketflow. And in this video, we're going to review and rate every single agent. And here is exactly what we are going to do. We are going to first ask ChatGPT to come up with 5 of the most wanted large language model agents and workflows. And here are the results. Here are the 5 large language model agents that we're going to build in one afternoon. And then we will throw these requirements to the coding agent, which is Cursor AI, to have it build all of them for us. And finally, this is the most important part. We're not just going to see if the code runs. We're going to rate its performance and then run each agent live to show you the result. The good, the bad, and the broken. So how is it possible for me to build 5 agents in just one afternoon? It all starts with a large language model framework I built called Pocketflow. It is a large language model framework in just 100 lines, but it is tiny but mighty framework that allows you to build any of the large language model application you want: workflow, agent, retrieval, augmented generation, you name it. If you want to learn more, check out all these friendly cookbook that are going through these example codes and flow design. We also have a documentation here that going through the basics. Now, because Pocketflow is so tiny and transparent, it lays the foundation to another concept I called agentic coding. The idea is very simple. You design the large language model application and agents will build it for you. So here I put together the agentic coding steps from the requirement, specification to flow design, utility, data nodes, and so on. This layouts the best practice, which we will see that in action very soon. I've also written a Substack post about agentic coding, the motivation and the setup, so you can support agentic coding for all these AI agents, including GPT Assistant, Cloud, or Cursor AI, Windsurf, and so on. So if you want to learn more about that, please check out this post. To make it even easier, you can use this Pocketflow template to get started with agentic coding. Now, if you want to use this template with Cursor AI, all you need to do is to copy and paste the repo URL to the clone repo. So now we have the Pocketflow project template right in your Cursor AI. And we can ask Cursor what is Pocketflow, and we can see that it is able to explain it perfectly. This is because we have this Cursor rule file that teach Cursor AI about the Pocketflow framework. Now we also have like a design doc such that we can let the Cursor AI build any large language model agents for us. So for the rest of this video, we are going to ask Cursor AI to help us build the 5 agents. We're going to go through each agent one by one with a technical review. We're going to rate them based on 5 concepts. First, the flow design, whether it can identify the applicable design patterns and have a high-level flow. Then we're going to rate the utility function, whether it understands utility and include only the clean necessary ones. Third, we're going to review its shared storage, whether it can design an efficient way to store and retrieve data. Fourth, how well it designed the nodes, which is each worker in the flow. And then finally, of course, we're going to implement, run the codes, and we're going to run them end to end. All right, so we're going to start with the first agent, Data Quality Guardian. It's going to clean a tabular data set, flag anomalies, impute missing values, and generate a short data health reports. We can use a synthetic data set of some CSV. I think 1 to 5 megabytes is too large. Let's just start with maybe a small CSV with hundreds of rows And we have the process of profiling, anomaly detection, fixed proposal, report writers. So all I need to do here is I just simply copy paste these requirements into the Cursor AI chat box and ask it to build the application for me. Usually you want to just start with the design doc and don't want to go ahead too much. So let's just run the agent mode, let the agents build this agent for us, and get back in just a couple of minutes. All right, in just half a minute, Cursor AI has already generated the design doc. So let's review this doc. All right, let's start by reviewing the flow design. So this is essentially a sequential workflow with 6 steps here: load data, profile data, detect anomaly, fix the errors, write the report, and save data. This at a high level makes sense, but I would say like the load and save data is not necessarily be included as a workflow. These are just very simple, steps that can be performed during the min file and the post processing steps here. But besides that, I think the high level design is good, so I will give it A- for the flow design. Now, when we talk about utility function, we're usually thinking about this utility function that is interacting with the real world, especially those that need to call remote API, like read from the email, call ChatGPT, write the results back to Slack channel. But reading or writing from the local file system, which is ambiguously not that a big deal. And also, why is calling large language model not part of the utility function? So for utility function, I will give it just a B- because it's pretty bad. Then let's look at the data storage. We configure the input output CSV path and the final report path. We have raw data profile, anomalies, fixes, cleaning, data cleaning, report. I don't know why to need to store fixes here, but it's okay. And also, what is the anomaly? It's not well defined here. So this is pretty concerning because it's not concrete. Are you talking about outliers? Are you talking about missing values? And how would you classify anomalies? How would you represent that? It's not fleshed out. So for the data, I will probably give it a B. Then let's read the node design here. As we mentioned, we don't want the load data. Then we have a profile node. It used the pandas info and describe function to profile data, which makes sense, but why is it a textual representation? I think the textual representation is pretty hard to consume by the downstream nodes. So I would recommend to generate a profile in a form of dictionary. And I think this links back to how to define anomalies in the shell store. Then for fix a node, for each anomaly, we're going to decide on a fixed strategy. That makes sense, but if it is for each anomaly, why we use a regular node instead of a batch node? So for more context here, in Pocketflow, we have a normal node, which essentially perform one action for one item, but we also have like what we call a batch node. So essentially for batch node, we kind of operate this action on iterable for like a list of anomalies, and we're going to fix each of these anomalies one by one. I think this is like the perfect use cases here. Then we have the report writer node, which calls a large language model to generate a markdown that summarizes the profile, which I don't think we really need a large language model to generate a report here, because large language model is really good at contextualize the problems in the real world, the scenarios. So I think it makes a lot of sense for fixed node to generate this anomaly using large language model, because they need to understand what this anomaly means in real life. But report writing is simply just concatenating these things into a markdown. So it's overkill. And again, we don't want to save data node. So the node design is also very ambiguous to me, so I will make it a B-. Since we have this list of review suggestions, let's just ask Cursor to fix them based on this advice. So we have the updated design doc. As we can see here, the flow is now much simpler, just has 4 nodes. We already have call large language model as the utility function. The shell store are also much cleaner. And for node design, we have the concrete definition of different anomalies, missing value, outlier, tab mismatch. And for each of this issue here, we also have a list of parameterized strategies that we can ask model to decide. Both the anomaly detection and the fixed nodes now become a batch node to go through each anomaly one by one. Now, this version looks much simpler, and better for me. So let's just ask Cursor help me implement the flow and also generate synthetic data for me to test it out. All right, in just a couple of minutes, Cursor AI has generated the flow nodes and the synthetic data for us. So this file and the utility simply generate an HR CSV with injected outliers, time mismatch. We can check out the CSV here. So we can find the issues of, for instance, not available, missing values instead of these tables. Let's look at its nodes implementation. We start with the profile nodes and call the pandas function to generate a profile. Then we have the anomaly detection nodes that, given this profile, focus on whether they have missing value, outlier, type mismatch, and so on. Oh, I guess that one issue here is it is trying to do a try except instead of exception, which is anti-pattern. Now, this is because in Pocketflow node, we already have the fault tolerance and the retry logic here. So you want to defer the exception handling logic to nodes built-in retry mechanism. And also, what is that? So for Pocketflow, you have 3 steps: pre-processing, execution, and post-processing. Pre-processing read data from shell store, execution operate on that, and post-processing write the result back to the shell store. Pre-processing just read anything it needs from the shell store and return that back. You don't store anything in the self instance. For the execution, you just get everything from the pre-processing. You don't access the shell store again yourself. And also, you don't have this try except logics in the execution. This is pretty bad. So let's write down dump. You don't handle error in execution. People reads all data from shared and return them. It should not use self. We never access data instead of execution. So we have Cursor AI help us fix the error handling and the shared store error for us. And the new version looks much better to me. So let's actually test it out. Awesome. So the script has just finished and we have this data cleaning report generated by the large language model application. So the report provides an analysis of data profile and identifies anomalies within the dataset and documents the actions taken to address these anomalies. So for each of these variables, we have a data types and statistics generated by the pandas data profiling function. We identify anomalies of missing value, outliers, time mismatch, and we apply a variety of fixed based on missing value imputations, outliers, thresholding, and the type casting. And we can also check out the clean data, without these missing values and the outliers. So I will give the implementation B, and I will say overall it's also a B for the whole data cleaning agents. But this is pretty decent still, given that it's just half an hour walk from the large language model agent. Amazing. So we have just finished the data quality guardian. Next, we will have a code review buddy. It accepts a zipped mini repo, explain what it does, measure the length and complexity, and suggest refactors. We're going to use a few small Python scripts to test it with deliberate code smells that are long function and duplications. And again, let's just simply ask Cursor AI to make the first pass. So we have Cursor AI just generate the agent design for us. Let's go through the design doc. So for the flow, we have 3 sequential stages. Structure mapper analyzes repo structure and explains what each file does here. It maps file relations and dependencies. Then we analyze the length and complexity using linking tools. Then we calculate complexity metrics. Cyclomatic complexity. I don't know how to pronounce that. I don't even know what it is. So this cyclomatic complexity is something developed by Thomas Metcalf in 1976. It's a metric used to measure the complexity of a program by counting its decision points here. It looks a bit outdated to me, so I will probably just not use that. But after we analyze the length and the complexity, we're going to refactor the code. We're going to create specific improvement suggestions that solve the identified issues and explain why each refactor improves the code. Then we're going to generate an executive summary. It's a business-friendly summary explaining the impact and priority with actionable recommendation wrapped by effort and impacts. That sounds good, but I guess we also need to provide some like an overview of the business to the model. Again, for the utility function, we don't want to have this read Python file. The local I/O operation doesn't worth it. But the code analysis tools makes good sense to me. Then we have the Python parse abstract syntax tree and generate diff. They make a lot of sense to me. Now for the data design, we have, I think, a much more concrete design than the previous one. I think it's maybe because we are using Cloud 4, not Gemini 2.5 Pro, but we start by providing the repo, the paths, all the files, structures, and so on. Then we're going to perform the analysis of each of the file. We're going to analyze the length, the complexity, duplications. Finally, we're going to refactor the codes based on the suggestions and generate a business-friendly reports. So next, let's take a look at the node design. We start with structure mapper node. These nodes read the repository files from the shared store and passes abstract syntax tree for each file using the utility function. Well, if it is for each file, it should be a batch node, not a regular node. Then it calls large language model to explain what each file does based on its structure and analyze file dependency and relationships. After that, we have the length and complexity analyzer nodes. These nodes read file contents from the shared stores. It runs length utility on each file. Again, this should be a batch node, not a regular node. Then it use measure complexity to get a matrix here. After that, we have the refactor generate node that for which identified issues call LLM to suggestions and store the suggestions back. Again, this is a batch node. And last but not least, we have the executive summary nodes that read all analysis and generate a technical report with metrics and diff with business-friendly executive summaries. So while we are waiting for Cursor to redesign the flow, let's also rate the code review buddy. I think the flow is like A-. It gets almost everything right, but just a bit too complex. The utility is also A-. It get everything right, but just Python file reading is just too simple to be a utility function. Data is also A-. I think it's pretty good, but you also want to include business context. The node design is a B because it just doesn't consider the batch node, which is a very important concept. So Cursor has already finished the redesign of our code review buddy. We can see that the flow is now much simpler. The utility doesn't include these Python local file operations. The data store also has a much more enriched context for the business. And also for the node, they are currently batch node for each file or for each issue. So let's just ask Cursor to implement and generate synthetic data set to test it out. Amazing, Cursor has implemented the code review buddy for us. So let's take a look. So we start with synthetic data sets of bad coding. So we have this process user data function that is doing way too many things. It should be broken down to smaller, more focused function. So it starts by validated imports, then it's processing, cleaning, creating timestamp, adding optional fields, and logging the results. After that, we have this duplicate logic function or Python code that fetch user profile from some URL, but we see the duplicate logics because we are fetching from this API, example API calls again and again without reusing them. We also have a messy calculator that the mouse function tries to do every possible calculation. This is way too long, has too many responsibility. It is convert string to numbers. It is trying to process different types of operations and apply any post-processing options to that. Next, it creates this utility function that analyzes your codes. It can help you find long functions that are longer than the threshold number of lines. I think 20 is a pretty strict threshold. A lot of good functions are above 20. So anyway, then we have a function called duplication detection that is trying to detect code duplication by, I think it is computing the edit distance or some similar metrics based on the lines. I feel like that's actually not the ideal way to detect function duplication, because we have seen a lot of code that has duplicate logics, but it can be implemented in a very different way, or they're different in a very nuanced fashion. So I will actually think that it's actually better to call the large language model to detect whether they have duplicated logics between functions. But it's a good starting point anyway. So next, let's take a look at the node design. We start with a structure mapper node that explains what the repo does overall. So this function starts by reading auto files from the code base. It creates a summary auto file, then it embeds the files into a prompt and asks the large language model to provide a clear, concise explanation of what this project accomplishes and return the overview back into the data store. I think this is good, but it only takes the first 10 lines as a sample to understand the code base. 10 is too small. Like in the modern code base, you have lots of files that you can't even read all the import in the first 10 lines. I would say that you can make it like thousands or tens of thousands, because modern large language model can usually takes hundreds of and even million tokens as the import context limit. Then you have issue analyzer node that finds problems in each file. It first fetch all the file and the content tuples for each of the file. Then it analyzes the long function one by one, which is from our utility function. But somehow it analyzed the duplication in the post-processing. So the long function is analyzed in the execution part, while the duplication is analyzed in the post-processing. That's a bit weird. I don't get that. And then next we have the refactor generator node that is a batch node. It takes a list of issues found from the previous node for batch processing. And for each issues, it decides what's its long function of duplication and has a customized prompt for different types of issue. But you can see that it obviously have the issue that it's trying to access the shared store in the execution part of the node, which is not allowed. And finally, we have an executive summary node that creates business-friendly report. So it takes all the issues and suggestions as input, then it first create a technical report, but technical one it's pretty easy. It's just a string concatenation, and then it generates the business report. This part requires a large language model because you're going to contextualize these issues within your business information. It writes a business summary and return the result back. Now this one looks pretty good to me. All right, let's ask Cursor to make the following improvement. The sample size of the lines of the code should be increased from 10 to at least 1,000. And also, why do you have 5 long functions in the execution but detect duplications in the post-processing? Finally, execution should never access the shared dataset. Awesome. So Cursor AI has just finished improving the functions. So we increased the line sample from 10 to 1,000. We also have a consistent analysis placement by introducing a new duplication detect node, and we remove the issue that we access the shared data from the execution step. That looks good to me. So let's just run the codes. All right, so the workflow has finished. We have our executive summary of our code reviews. So it identifies a lot of those duplication issues and try to refactor the codes. For instance, trying to have this get header function, which was duplicated a lot of times in the original code, and replace that with a simple function call. We're also trying to avoid this redundant API calls, JSON header, and so on. And we also provide a business impact to convince the stakeholder Code quality issues like long functions and code duplication slow down development and increase costs because they make the code base harder to understand, maintain, and update, leading to longer development times. These issues also heighten the risk of errors, resulting in unreliable product performance, blah, blah, blah. I think this part is a bit general and kind of like bullshit. But anyway, I think the overall the results are pretty decent. The workflow runs successfully. Now, I think there are a lot you can improve to making sure that the workflow is more interesting. For instance, you need to call large model to detect these errors. And also the business contextualization should be much, much more enriched. But anyway, it's a very good starting point for you to bootstrap a code review buddy. And finally, let's finish our rating of our code review buddy. I think the implementation is like a B+. It messes something up like the batch node and also access the shared store in the execution step. But overall, it's still a solid implementation. And overall, I will give the code review buddy implementation an A-. I think it's pretty good implementation. The design, the utility, the data structure are all pretty decent. The node is a bit off, but still fixable. And I think this is a good starting point for you to have a really complex code review. So next, we're going to use a paper to flashcards converter. The purpose here is to read one or more PDFs, draft a one-page cheat sheet, and auto-generate spaced repetition flashcards. So we can use a synthetic dataset like a PDF with section, equation, figure. We're going to read the PDF. We're going to summarize sections, generate question, answer, and the flashcards. The output is a markdown and an Anki deck and a summary sheet. I think that agent is actually quite useful. I would personally use that myself. When I was reading some very important textbook, especially before an exam, I need to cram this knowledge, and the flashcard is actually very powerful. All right, so let's just simply paste the requirements into the Cursor chat box and ask Cursor AI agents to help us design the agents for us. Amazing, we have the design doc ready, and let's take a look. So this is the flow design. It follows a workflow pattern. It has 5 steps here, but why is the flow so complex? I think the flow diagram is not right. It should only have like 5 nodes, and we don't usually have branching for workflow. The branching in Pocket Flow is usually for agent when the agent has different decisions, and you can have one branch for each of decision. But let's just read the steps here. We can load the PDF. You can summarize the section, extract question, answer, format flashcard, and generate cheat sheet. I think that is interesting, but how would you know the section here? I guess my question here is, how do you identify the section from just PDF? Usually this is something, you need to extract yourself. You need to figure out, oh, this text is section 1, this text is about experiment section, this is about a conclusion. It's unclear to me how you can just directly derive that from the PDF. For the utility functions, you have to extract PDF into a text with such keys, text, section, metadata. I would be surprised, how would you do that? And then you call large language models. You format Anki deck, which is, I guess that's fine, but let's just simplify that. We don't really need to convert it into Anki compatible format. Save markdown, this is not needed. This is just a simple local file operation. So that doesn't need to be a utility function. Next, we have the data structure. We have a list of all these import PDFs. We have some configuration. Then we're going to extract all the raw text and the sections from the PDFs. And we have some metadata. Why do we need that? I don't get this author's total page. I think this is just something the agents think is fancy and good to have, but it's not needed. So I would say that it's pretty redundant. Then we have the process content that summarize each sections, generate question answer pairs, and we have flashcards, cheat sheets, Statistics, it's a bit over. Anyway, next we have the node design. We start by load the node. And I think the extract PDF task is doing a lot of heavy lifting here. It is trying to magically get all the sections from the PDF. That's too much. You need to do this OCR, you need to pass the test, identify the best bullet points. It's just too much. Then we're going to summarize the section. Why do we need to summarize section? Again, I don't fully get that. And we're going to extract question answer from the summary. That makes sense. And we're going to format flashcard. Okay, I think this is essentially like each question answer itself is one flashcard. And we're going to generate cheat sheet based on the section, and we're going to save the output. I feel like there is some redundancy because my feeling is that cheat sheet itself is summary. So I think the cheat sheet and the section summarizer, they are doing almost the same things, but with just different naming. So here are all my feedbacks to this design doc. Firstly, the flow design seems like it's only have 5 steps, but the flow diagram is very, very complex with branching. And also the extract PDF utility function seems to do a lot of things. Maybe just make it PDF to test. And also we don't need to format Anki. Question answer pairs are already good enough. We don't need to save Markdown as a utility function. It's just a simple file IO locally. Share store is very complex. Like, why do we need author names? Just simplify all these unnecessary ones. Section summarizer node seems to be redundant to the cheat sheet node. Remove it. Instead, you have a text from a PDF and you label the text into multiple lines. You then have a new node trying to identify the section from the PDF text. That node should output a list of line numbers. That is the place to split the PDF text into sections. And finally, we don't need the save output nodes because that's essentially just a file IO in the post-processing step. So when we are waiting for Cursor AI to finish improving the design doc for the paper to flashcard agent, let's quickly rate it. So for the flow design, I will give it B-. I don't think Cursor did a good job. The flow doesn't organize well. The diagram doesn't make any sense. For the utility, I will give it a B+. I think it's all good, but the PDF extraction utility function is just doing too many things. It is trying to extract PDF text. It is trying to do OCR and also trying to extract author list section, a bunch of different things. The data schema is also a B+. It gets most of the point right, but it's just over complex. It's trying to include a bunch of unnecessary information like who is the author of this paper. No design, I will give it a B because it has lots of this redundancy in terms of the purpose of these nodes. For instance, the section summarization is quite redundant to the cheat sheet generation. All right, Cursor has improved the design doc based on the previous feedback. So it has greatly reduced the complexity of the workflow. Now it is only 4 nodes: load PDF, detect section, generate question answer, and create cheat sheet. There's no Anki format. The PDF extraction utility function is now much simpler. It is only string in, string out utility function. And we also make the share store schema much simpler. We don't have the extra author list. The node is also much cleaner. We have the text section that try to split the text, and we don't have this extra node that's try to summarize the sections. This looks good. Let's just ask Cursor implement the paper to the flashcards. And we don't want to use the synthetic data set because I think it's actually a quite useful agent for me. I will just use my own paper that I want to read and test it out. Amazing. So Cursor AI has successfully helped us implement the 4 paper to flashcards. Let's take a look. So it has this PDF extraction function that uses PyPDF to extract text from PDF. But the error handling logic is not needed here, as we discussed before. If it fails, just let it fail, and we have our own error handling logic for them. Now let's look at the nodes here. So we start by load PDF, which is use this utility to extract text from PDF. Then we have a detect section nodes. It gets the raw text we just extracted from the PDF, label them with line numbers, and ask the large language model using this prompt to identify all these important sections with titles and the start and end line. Now, this 5,000 is really annoying to me because it is kind of assuming that the text is only 500 lines and everything else is just cropped away, which I guess the problem here is that most of the model are trained based on the impression that large language model prompt is very limited, which is no longer the case. We have the best model that takes hundreds of thousands or even millions tokens as the input context. 5,000 lines is just nothing to it. It can be much, much larger. So this should be removed. And also it's also doing all this try except logics, which again is a bad practice. Then we generate question answer from this section content. We identify the key concepts, important facts, methods, approach, and provide a list of questions. This is pretty good, except the cropping and the try except logic here. Finally, we have the cheat sheet. So basically, create a concise cheat sheet summarizing this academic paper with the section content. Here, there is a for loop for that concatenate the whole section together. So this is essentially just the raw text that is a cropped version. I think this just get the whole raw text as simple as good enough. So let's just ask cursor, remove the error handling logics in the utility function and the node execution part. Pocketflow has its inner error handling logic and also remove all the cropping of text and content because current large language model have large context window to handle these large texts. Awesome. So Cursor AI has helped us improve the implementation by removing all this error handling logic as well as the text propping, as current large language model has much larger context window. So let's test it out. I will use my favorite paper, DeepSeek R1 paper. Basically, it trains large language model for reinforcement learning. Let's use our paper to flashcard agent to analyze this paper and generate flashcard from it. Now it has finished the generation process, and let's look at the question answer flashcard pairs it generated, which is pretty good. For instance, what are the challenges faced by DeepSeek R10? It faced the challenges of poor readability and the language mixing. What is the significance of open sourcing these models mentioned in the study? So they have 6 dense models supports research community. And also, what is the most important focus of the research? The most important focus is to improve large language model reasoning using pure reinforcement learning without any supervised data sets. Overall, I would say that this is pretty accurate and it kind of captured the most important points inside of the paper. Now, we can also look at the cheat sheet. If you don't love the style of flashcard, a cheat sheet is a good way for you to just grab a quick summary of this paper. And this also looks pretty good. So we have all these important methods on the group relative policy optimization, reward model, code starting, reject sampling. That is indeed the most important methods for this paper. Now, imagine this cheat sheet and the flashcard for your most important courseworks. You can generate these things, before your final exams, and you can just cram every knowledge within a few days. So let's give a final review on how well Cursor helped us implement this paper to flashcards agent. I think the implementation is okay-ish. I will give it A-. It missed some points in terms of error handling and the cropping, but for the rest of the information management, it does a pretty good job. And overall, I will give it a B+. I think it gets most of the important ideas correct, but still the initial flow design, the nodes, the data is over complex, and also there is a lot of redundancy. All right, next up we have the narrative BI analyst. Transform raw KPI tables into a trend chart code, apply English weekly update, and a slide outline. So we're going to use some synthetic data set of 30 days of fake daily KPIs, like sign up, daily active users, retention rate, revenue, and the output is some BI reports with natural language explanation. So let's copy and paste the requirements into Cursor agent chat box and ask it to make a pass to design such large language model flow for us. Boom, we have our narrative BI analyst design ready. So business analysts spend hours manually reviewing KPI dashboards, identifying trends, and creating executive summaries. The narrative BI analysts automates this process by transforming raw KPI data into actionable insights with visualization, plain English summaries, and presentation-ready slide outlines. So we have a sequential workflow that starts with the insight spotter, which analyzes 30 days of KPI data to identify trends, anomalies, and key metrics. Then we have a natural language storyteller converts insights into plain English weekly update. Finally, we have a slide skeleton builder that creates presentation-ready slide outline. So when I was reading this flow design, I think that it is very complex, and each individual node has too much responsibilities. So for instance, for this insight spotter, I need to calculate week-over-week changes. I need to compute statistics, generate visualizations, and also identifying key insights from this data. That's three, I would say, very different tasks here. And if you really want to perform all three tasks here, you should use three different nodes here, not just a single monolithic nodes that do everything. So next, let's go through the utility function. So we start with generate chart code. This looks to me like generating visualization. Then we have analyze KPI trends here. We have 30-day KPI data frame as inputs and also output the dictionary with trend analysis of growth rates, correlations, and anomalies. So I think this is mostly trying to extract statistics. We have core large language model, of course, and we also have a data sampling. Oh, this data sampling is mostly just used for test data. That's okay. Yeah, so we have also an example implementation of the key KPI analysis. I will call this not an analysis, but just computing the KPI. Next, we have the shell data store. We start with the raw data that contains all the 30 days of KPI data sets. Then we analyze the data range, we draft insights of trends, chart code, key findings, and we output the report, slides, chart files. I think the output is a bit complex. Maybe we can just say that we don't need to concern about. So for instance, the chart files, just give me like a markdown file is good enough. Also, I guess how do you generate visualizations? Is this just hard code a list of visualization to generate, or do you generate visualization based on the understanding from large language models? It's not very clear for me. And let's look at these nodes here. So again, the insight spotter node is pretty monolithic. It is calling a lot of different utility functions. That's very overwhelming. Natural language storyteller node, that's okay-ish. You just get the insights as inputs and outputs the natural language narrative. Then we have the narrative from these storyteller nodes and build that into the slides. That makes sense to me. So here are the two questions I will ask our Cursor AI agent. One is insight spotter seems to do three different things. You should either make it three nodes or simplify it. Also, how do you decide which visualization to generate? Is it hard-coded, like the chart type is hard-coded list, or is it something depends on large language model decision? So for our BI analyst design by our Cursor AI agent, I would say that the flow is A minor. It gets most of the power right, but the first node is a bit monolithic. For utility function, it's okay-ish. I will also give it A minors. It gets most of the power right, but whilst it's analyzing KPI, while it's computing KPI, it's a bit confusing. The data storage is okay. I will just give it A. I don't see any major issue here, but it may just make it a bit complex. But that's more like, maybe a flow design issue, not a data storage issue here. The node, I'll give it B because, as we discussed, the first node is just too monolithic. It's calling two utility function, and I think it's also calling large language model. It's just a very bad practice. So Cursor AI has already refined the design doc here. Let's take a look here. So it breaks down the monolithic nodes into two nodes. One is data analyzer, and another is chart generator. The data analyzer seems to be mostly computing some statistics from the KPIs, and then we use rules plus large language model to decide chart types here. The way to generate chart types is based on a hybrid approach of simple rules plus large language model refinement. So we have a base rule, can be mapped to line charts, metric comparison can be used by bar charts, correlation we use scalar plot, then we enhance by large language models. So for each insight, we ask large language model to suggest the most effective chart type and styling. For instance, given an insight about 25% sign-up growth, should we use a line chart, bar chart, or combination chart? Consider the audience as executive. We have analyzed KPI trends, calculates the statistics. We also have the suggest type that recommends chart type and styling suggestion. I'm not sure about generating chart codes, suggest chart types here. I think this is more. It really depends on whether the suggest chart type is using this base rule here, or is it using large language model enhancement. If it's using large language model enhancement, you don't want to use a function. You don't want to have a utility function that wraps the core large language model here. This is a anti-pattern because it's much better to just show the raw prompt in the node. It's much easier, much transparent to understand what's going on. So I have just drafted a quick questions asking Cursor for this just chart type utility function. Is it calling large language model, or is it just using the rule-based logic? If it's calling large language model, then should not be a utility function because this should be the core logic in execution. And it turns out that it is not really a utility function, rather it's really internals. So Cursor has updates the utility function. Instead of having this magical way to recommend chart types, it just gets the base chart type. It just uses a basic rule function to recommend what chart to use based on the column types. Now for the node design, the chart generator node goes through each significant insights called base chart types for initial recommendation, then use large language model to refine chart choice based on the insight context and the audience. Finally, it generates chart code to create acceptable visualization code. But if it's for each significant insight, why is it not batch nodes? That's so stupid. So let's just ask Cursor, why don't you use batch node? All right, so we have Cursor fixing these stupid issues on the node versus batch node. So let's just ask Cursor to implement the whole data analyst for us and generate some example input to run a whole analyst agent. Awesome. So the narrative business intelligence workflow is ready. We have 4 nodes as we discussed before, and the nodes are implemented in this function. We start by analyze data. So we perform basic statistical analysis on our KPI data set. We fetch the data from our shared storage and we analyze KPI trends. This is this utility function. So if we look at this utility function, what it does here is it is calculating some statistics like week over week changes for all metrics here. It also computes the overall growth rate, find a correlation between different metrics, detect anomalies, identify most significant insights, and so on. So basically just compute some interesting and the standard statistic that is used for model to better contextualize the information. Then we generate charts. For each insight, we're going to ask the model to recommend the best chart type. So we have the get base chart types. This is essentially the simple rule function. So given all these different, data types, metric names, we're going to recommend some basic charts. If it has comparison, we use bar chart. If it's revenue, profit, we use area chart. If it is percentage, we use line chart and so on. Now, this basic recommendation is then fed into the large language model to provide a more detailed, tailored recommendation. Here, again, is using some error handling logic, which is not recommended. Usually you want to use Pocketflow's own fallback mechanisms, not in hard-coded one like this. But overall, it makes a lot of sense to me. Then we have this natural language storytelling node. You are a business analyst writing a weekly KPI report for your company. This is your data summary. This is key metrics. This is all these statistics we built before. You're going to write a compelling 300 to 400 word executive summary that starts with the most important insights, explain trends, provide context, and ways for executives. And after all these insights, charts, business executive summaries, we're going to create a slide deck in the form of, a structured output that includes for each slide what's the title, what's the bullet points, what's the speaker notes, and so on. That looks good to me. Let's test it out. So Cursor AI has already generated this synthetic KPI dataset. It looks like this. So for the whole months in 2025, May and June, what is the business metrics of sign up, daily active user retention percentage, revenue? This data, if you look at that, is pretty dry to read. So we're going to generate more insights to make it business friendly. So let's call our workflow Python man, and it is starting the narrative business intelligence analysis that transforming raw KPI into insights, charts, and presentations. We already have some high-level metrics, the average and total revenue, but now we are going to use large language model to have a more in-depth analysis. Hooray, we have the workflow finished, and we have a comprehensive markdown report ready here, along with all these generated charts and insights. So let's take a look here. So this is the executive summary, company tech flow analytics analysis period. 3 days analysis generated on June the 29th. In the 30-day period, tech flow analytics experienced robust growth across key performance indicators, underscoring the efficacy of our recent strategic initiatives. Let's see the key insights here. Now, the sign-up grew by almost 40% over the period. Daily active users grew by 47%. Revenue grew by 43%. Strong positive correlation between sign-up and revenue. Pretty strong correlation between daily active users and revenue. We also have different charts that shows this impressive growth. Let's take a look at the charts here. So we have a chart folder. The first one is daily active user growth, which looks pretty, I love how it has zigzags over the day, which looks somehow realistic. Then we have the detected anomalous retention percentage. I guess this too. Impact of signups, revenue growth. So this is a correlation between the number of signups and revenue, which is pretty obvious. Revenue growth, signup growth, daily active users and revenue, signups and daily active users. Okay, that looks pretty decent. We come from this just a single table that is pretty dry to read to all these charts and a nice BI summarizations. So this is pretty good. We also have these slides ready. Okay, so finally, let's read the BI analyst built by Cursor AI. I will say the implementation is an A-. I mean, it does the implementation pretty well. Everything's implemented. It generates the visualization charts, it generalizes the business insights into Markdown. But it also have this error handling logics here that is not the best practice. So overall, I will give it A-. This is pretty good, given that we're coming from a single dummy tables into all these nice charts and business insights. So we have just finished our narrative BI analyst. Next, we'll have our Socratic tutor simulator. We will launch an interactive tutor that quizzes, hints, and adapts difficulties in real time. We will use some JSON topics outline the Bloom taxonomy tags. We're going to plan the curriculum, generate questions, evaluate answers, and have an adaptive coach. This is a live chat tutor that provides this mastery report. So I think this will be very interesting because this is not a workflow. This is a raw agent that, make decisions in real time based on your input. Again, let's copy paste the requirements to the Cursor chatbot and ask Cursor to make the initial pass with the design doc. Boom! Our Socratic tutor simulator design is ready. Students need personalized adaptive tutoring that adjusts to their learning pace and understanding level in real time. Traditional static content doesn't provide the dynamic questioning and the hint given that effective tutoring requires. So the design pattern is agent plus workflow. The agent part is a tutor that makes dynamic decisions about next actions, question difficulties, hint provisions, topic transitions, and so on. Then we have a workflow pattern that structured tutorial session with clear phases. Now, this is the high-level flow design. So we start with a session and we plan the curriculum. Then we have Socratic tutor agents that decide whether it need to ask question next, or do it need to give hints, evaluate, adapt, and session. So here's the main flow components: curriculum planner, analyze topic outlines and student history to select starting points and learning objectives. Socratic tutor agents, central decision maker that determine next action based on students' current understanding level, response quality, learning objective, engagement indicator. To be honest, it's a bit complex. And it's a bit high level, so I don't really know how you can get student history and what do you mean by starting points, what do you mean by learning objective, and why do we only have question generator, answer evaluator, adaptive coach, but not hint provider? Where does this go? It's not in the list here. And last but not, and I don't understand why this evaluate is part of the action. I think this is part of your Socratic tutor agent jobs. You are agent, you evaluate, you decide whether you need to go to question, whether you need to provide hint, whether you need to adapt changes or not. So it's not clear to me like what means here. And I don't know what is adaptive coach and adjust difficulty. What do you mean by adjust difficulty? It's a bit high level. Is it changing curriculum? Is it shifting topics? It's a bit hand waving for me. Next, let's read the utility. We start with load curriculum. We don't really need a utility that just load local IO. So I think this is not needed here. Chat interface, we don't need that. No, it's just a simple input. We don't need a save session data. Maybe we need generate report. We have the shell store design here. We have all this curriculum as the topics. I think this is pretty concrete because we have like what is inside each topics. We have the ID, the name, the Bloom levels, prerequisite concepts. Then we have the student current level, mastery scores, learning style, session start date. We have session of conversation history, current question, attempt count hints. We have the performance, question attempted, question correct, average response time, hint usage rate, difficulty progression, engagement scores. I don't know how to get engagement scores and the results, mastery reports. I think this is okay-ish. I love the shell store. I think this is pretty detailed, but just some concept is pretty high level. Then we have the node design. We have a curriculum planner, read curriculum JSON file and study, and the student history, select appropriate study topic and learn objectives based on the student level. Then we have this tutor giving this decide next action based on the large language model reasoning, question generator, answer evaluator, adaptive culture, mastery. I think the node design is okay-ish. So this is my overall feedback to the design doc. It is not concrete enough. It's a bit hand-waving. For instance, why do we need hint provider? It is shown in this diagram, but it's not really a node. Either remove it from diagram or just add a node. It's unclear to me what do you mean by engage indicators and so on. I just simplify it or make it them concrete. What is answer evaluator? Be concrete. What is the input and output? Why do we need that? Look, to me, it is part of the job of the tutor agent. And why do we need an adaptive coach? Again, it's very hand-waving. It's adjusting difficulty, which I don't know what it means. So let's ask Cursor to make it more concrete. So for our Socratic tutor, I would say that the flow is a B because it's very complex for no good reasons. The utility is actually also like a B because it is including a lot of unnecessary utility like reading local file or have a command line interface. That's pretty easy to implement. It's not really the essence of the utility. The data storage is good. I'll give it an A. It's much more concrete and flash out. The node design again is a B because it's very confusing. A lot of nodes is doing some very hand-waving job that is very hard to comprehend. So this is our updated design doc for our Socratic tutor, which is much more concrete. We have a much simpler flow. So we're just starting from the curriculum planner. We go for the Socratic tutor agent. It just have two action. One is ask question, one is to answer session. Now, this is much elegant, and I don't think we need that complex agent action space anyway. I love the simplicity that we have a tutor agent that does the evaluation, provides hint, adjusts difficulty, decide next session all in one node. That's very simple, easy to follow. For the utility, we only have the core large language model. We don't have all this unnecessary read JSON and also the chat interface generation that is a very obvious task here. The shell storage is already pretty good and it's also even better simplified. We also have the Socratic tutor agents question generator master report node well designed. So let's ask Cursor to implement these Socratic tutor agents. I always want to learn quantum computing, but it's just very hard for me to get started. So I want to let this agent teach me about quantum computing in a very friendly and adaptive fashion. So long story short, the Socratic tutor generated by Cloud4 is horrible. So I have opened up a new chat section with Gemini 2.5 and has it re-implement the tutor workflow for us. So this is the new design doc here. The changes is actually minimal, but we start with the tutorial nodes that first teach you the topic. Then before we jump directly into the question answering process, we can inspect the nodes. We start by planning the curriculum. And also I changed the curriculum to be more like a philosophy of happiness, not quantum computing, because I find quantum computing highly confusing. It's not really something that is suitable to be questioned in a Socratic style. But if we look at the curriculum of the philosophy of happiness, it is pretty interesting. So we have these questions like, a new technology offers a happiness machine that guarantee you a life of constant pleasure and no pain. The catch, you have to plug in for life and all your experiences will be simulated. Would you plug in? What is the potential downside of guaranteed pleasure? The answer is pretty general. I would say the downside is the loss of reality, free will, authentic human experience. I don't know, man. Maybe we are already in a simulated world right now. But anyway, we loaded all this curriculum into the shared store. Then we large model to start by teaching us the philosophy of happiness first. Then it will ask you a bunch of questions. You are a Socratic tutor. The student just answer a question. The correct answer is what the current attempt, the hints given. Evaluate the student's response. Your response must be YAML, blah, blah, blah. Then it will going through, get to the user input from us. It will first generate new questions and finally generate a master report of the study. So let's test it out. Let's ask Ming, Python man.py, and boom. Imagine you could live a life of endless pleasure without ever being truly happy. Would you choose it? This starts your exploration of happiness. Is it just fleeting feeling or something deeper? How do you define happiness? And it can actually be attained. If someone had all money, friends, and the success they could ever want, but still feel empty instead, would you say they are happy? Well, why not? I would say they're not. I would say they are not because they felt empty. Obviously, it doesn't get a point. So our Socratic tutor is giving us more hint. Like, think about what it means to be truly happy. A material wealth and a social success enough, or is it something deeper, such as sense of purpose or fulfillment? I would say like they are not happy because they don't fulfill their purpose of life. Okay, I don't know what I'm answering, but let's see how it goes. You are on the right track by mentioning purpose, but try to expand on the idea that happiness involves more than just fulfill external goals. Think about the role of internal states like inner peace or personal meaning. So they're not happy. They need to fulfill inner purpose to external world. Let's see how that goes. The feeling of emptiness despite having all external goods, just that they're not truly happy, and as happiness is an internal state, the person might achieve happiness by finding their inner peace, purpose, or meaning beyond material wealth and external validation. This answer emphasizes that the true happiness often requires more than just possession or external success, aligning with the idea that fulfillment comes from within. I think it is like a yes for the answer. So the question changes to begin to think about time you felt truly deeply happy. Was it a moment of intense joy, long-lasting feeling of peace, and contentment? Describe it. A time when I feel truly happy. I'm not going to continue this conversation, but we get a point. So let's wrap this up by providing the rating for our Socratic tutor. I would say the implementation is actually a B minus. It missed a lot of points. The experiment is a bit awkward. It's not really a teaching process. It's basically asking me a lot of question that doesn't have enough context, and the hint is also a bit abrupt. I would say it goes back to the problem of the design. The design is very confusing to me. It's unclear to me what is the teaching experience look like, what kind of question you're asking and answering for, how does the feedback works. It's just very hand wavy. It's just saying, oh, we want to have a great teaching experience, we want to let students learn gradually, but without a concrete design and definition. And overall, I would say that Cursor didn't do a good job in terms of building this Socratic tutor. It's a B. Now that's it for this videos. We have generated 5 large language model agents and workflow in just one afternoon. Now, the secret here is both Cursor AI agents and Pocketflow, which makes it very easy to build all kinds of large language model applications. Now, my favorite is definitely the flashcard generators, because I think this one will be very practical and it is also well executed. I guess the biggest takeaway is that if you want to build any of these large language model application using agentic coding, the most important part here is you want to focus on design. So for instance, I don't like the Socratic tutor built by Cursor AI, and its design happens to be very horrible. It's pretty hand-wavy. It's unclear the definition of how you're going to adapt difficulties. So the real role for human to build agents is to making sure that the design, the definition is concrete enough, so the AI agents is able to implement your idea concretely. But anyway, hope you love this content, hope you enjoy the journey. I'm also thinking about building more large language model agents or applications using agentic coding. So if you have more ideas on what kinds of large language model agents or workflow you want to see me build, please leave that in your comments. But these agents or workflow do need to be not that far reaching. We do want something that is implementable, and also ideally we want to have some way to test it out using some data sets. But that's it for this video. Please leave a comment for what you want to see in the future, and I will see you in the next one.